Hi, in this video, we are going to discuss implicit differentiation. It's actually a very useful differentiation technique. But first of all, what does implicit mean here? A function can be either given explicitly in the form of y equals f of x, or it could be given implicitly in an equation. For instance, if you have y equals square root of 1 minus x squared, then here function is given explicitly. Like you can write it like y equals some function of x. But if the same function is given x squared plus y squared equals 1, then it's called implicitly. Okay. And another example, if you have the function given like cubic root of 2 minus x to the fourth, then this is explicitly given. But the same function could be given in an equation like x to the 4 plus y cubed plus 2 equals 2. This is implicitly given function. Well, both of the examples, like in the examples, the same functions, but the first one is explicitly given, the second one is implicitly given. But however, sometimes there will be functions which will be given implicitly in an equation, and we cannot write the function in an explicit way, but we still need to find the derivative of that function. So in that kind of case, we will use implicit differentiation, and this will happen quite often times actually in real life. This is most of the cases. Like you don't usually, given the functions to you in a nicer explicit ways. Most of the times you may have to deal with equations. So anyway, let's do an example. Example 1. Find y prime if function y equals f of x is given by x cubed plus x squared y minus y to the 7 equals 5. So first we take the derivative of each of the terms with respect to x. And then now we have 4 terms here. The first term and the fourth term are easy to differentiate. The first will be derivative of x cubed is 3x squared and derivative of 5 is 0. What about 2? Well, 2, we have product of two functions here, x squared times y. Remember, y is a function of f. It's not just a letter, it's a function. So we could have written just x squared times f of x there, same thing. So we apply product rule for that. That means derivative of x squared times y plus x squared times derivative of y. And then the third term, y to the 7th, that's actually a chain rule. We need to use the chain rule. Why? Because y is f of x. F of x to the 7th power, there's a chain rule for that. We have seen it in the previous example, in the previous video. So we have to use chain rule for that, which is going to be take the derivative of the 7th power. So minus 7 times y to the 6 times derivative of y, which is derivative of the base. So when we take the derivatives here for the product rule, we have 2xy plus x squared y prime also coming. Now we are done with the derivatives. So we solve for y prime because we want to find y prime. So we keep the y prime terms on the left. We take the other terms to the right. So this way we can factor y prime on the left, which becomes this equation. And then if we divide both sides by the term next to y prime, we are going to get y prime. Okay. Another example. Let's say if y equals f of x is given by x to the 5th plus 3xy minus e to the y plus sine y equals 10. First step, we take the derivative of each of the terms. So x to the 5 has derivative 5x to the 4th. 3x times y is a product of two functions. So we take the derivative of 3x times y and then plus 3x times derivative of y. And then minus e to the y, chain rule. So the derivative of minus e to the y will be, remember from the chain rule, like e to the f of x has derivative e to the f of x times f prime. So here y is f anyway. So that's going to be minus e to the y times y prime. And then plus sine y. Well, sine y also chain rule for that. Why? Because remember, sine of f, derivative of sine of f is cosine f times f prime. So this is going to be sine of y, derivative of sine of y will be cosine of y times y prime, because y is f of x. I mean, I could have written f of x instead of y, okay? And derivative of tan is 0. Now we are done with the derivatives. Now solve for y prime. Take the y, I mean, keep the y prime terms on the left, take the other terms to the right. And so we are gonna have this equation here, and then factor y prime on the left, and then we will have the second equation, excuse me, and then divide both sides by the term next to y prime, and then we get the result for y prime. Another example, let's say the equation is x squared plus x to the 4 times y plus y to the 6 equals 3. And then first we want to find y prime, that's the A part. B part, find y prime at the point minus 1, 1. And that gives actually the slope of the tangent line to the graph of y equals f of x at the point minus 1, 1. And then C part, find an equation for the tangent line to the graph of y at minus 1, 1 point. So first we take the derivative of each of the terms. Derivative of x squared is 2x. For that x to the 4 times y, we have a product there again. We apply product rule. So derivative of x to the 4 times y plus x to the 4 times derivative of y. Well, derivative of y to the 6th chain rule, that's going to be 6y to the 5th times y prime. Derivative of 3 will be 0. So when we take the derivatives, we are going to have this second equation. And then, done with the derivatives, what's going to happen? We keep the y prime terms on the left, take the other terms to the right. So we get this equation, and then factor y prime, then divide both sides by the term next to y prime, which is x to the 4 plus 6y to the 5th, and then we get y prime. So this expression is the derivative expression for this function. That's part A. Part B says find y prime at minus 1, 1 point. So that means plug minus 1 for x, plug 1 for y in the y prime formula. That's going to give minus 2 times minus 1, minus 4 times minus 1 cubed plus times 1, all over minus 1 to the 4th plus 6 times 1 to the 5th. So when you simplify this, that's going to be 6 over 7. Now this 6 over 7 gives the slope of the tangent line at point minus 1, 1. The last part, we want to write an equation for the tangent line to the graph of the function. Well, then we just write y minus y coordinate, which is 1, equals the slope 6 over 7 times x minus the x coordinate, which is minus 1, because the point was minus 1, 1, right? So when we simplify this equation, we get the tangent line equation, which is 6 over 7x plus 13 over y, 13 over 7.